Welcome! Today, we are cracking a classic coding interview problem. It looks pretty simple on the surface, but it has this really clever twist that can trip you up if you're not careful. We're talking about LeetCode 80, remove duplicates from a sorted array II.
Okay, so here's how we're going to tackle this. First, we'll get our heads around the problem itself. Then, we'll try a simple approach, see where it falls apart, and use that to build up to the real optimal strategy. And you'll definitely want to stick around for the end, where I'll give you a cheat sheet with all the key takeaways for your next interview.
All right, first things first. Let's make sure we have a crystal clear picture of what the problem is actually asking us to do, because the details are everything here.
So we get a sorted array of numbers. The two big rules are, first, we have to do this in place. That means no creating a new, separate array. We have to work within the array we're given. Second, and this is the crucial part, each number can show up at most twice. So 1 5 is fine, 2 5s are fine, but 3 5s, not okay. And at the end, we just return k, which is the new length of our modified array.
Let's look at an example. Imagine our input is 1, 1, 1, 2, 2, 3. See that third one? That's a problem. Our rule says we can only keep 2, so we need to effectively get rid of it. Our final array should start with 1, 1, 2, 2, 3. That's 5 elements, so we return k is 5. And don't worry about what's in the array after that 5th spot. It just doesn't matter.
Now, before we dive into our exact problem, let's warm up a little. We're going to look at its easier cousin, which is just called remove duplicates from sorted array. This is going to give us a solid foundation that we can build on.
For that simpler problem, the classic solution uses 2 pointers. You can think of it like this. You have a read pointer, J, that's the explorer. It just scans through every single element. Then you have a write pointer, I, who's the gatekeeper. It only moves forward to let in a new, unique number that J has discovered. This works like a charm when you can only keep one of each number. But here's where it gets really interesting. That simple, elegant logic, it totally falls apart the second we introduce our new rule, allowing duplicates up to 2 times.
The whole problem boils down to this, going from keeping 1 of each number to keeping up to 2. In that first, simpler problem, our gatekeeper pointer only had to look at the last number it wrote down. But now, it needs more information. It needs to ask itself, okay, I see a 2. Is this the second 2, which is fine? Or is this the third 2, which I have to get rid of? Comparing to just the last element isn't enough anymore.
So let's just trace it in our heads for a second. With that simple logic, it would keep the first one, it sees the second one, thinks duplicate, and skips it. Whoops, already wrong. It would keep the first 2, then see the second 2, call it a duplicate, and skip it too. The whole thing just doesn't work.
The simple logic fails because it only has a memory of 1. When it gets to that third 2, it compares it to the number that came before it in the modified array, which was the second 2. It sees they're the same and throws it out, totally clueless that we were actually allowed to keep that second one.
So clearly, we need a much smarter approach. We need a bit of a mental upgrade. And the key is to stop thinking about one element at a time. We need to start thinking in terms of entire streaks of identical numbers.
And this quote just nails the change in thinking we need. We're going to stop asking, is this single element a duplicate? Instead, we're going to start asking, okay, I've just landed on a 2. How many 2s are there in a row right here? Once we know the size of the group, we can make a much smarter decision. This new algorithm is way more powerful. We use 2 pointers, a left one for writing and a right one for reading. The right pointer finds the start of a streak, and then a little inner loop runs ahead and counts how big that streak is. Then, we make our decision. How many do we keep? Well, it's the min of the streaks count and 2. We write that many copies using our left pointer, and then, this is important, we jump our right pointer past the entire group we just dealt with.
Okay, let's walk through this with an example. Both our left and right pointers start at index 0. The right pointer looks ahead and sees a streak of 2 zeros. The count is 2. We're allowed to keep up to 2, and min of 2, 2 is 2. Perfect. So we write both zeros back into the array. Our left pointer, L, now moves up to index 2, ready for whatever comes next.
So now our right pointer is at index 2, which is where the 1s start. It scans ahead and finds a whole group of 4 1s. And here is the magic step. Even though we found 4 of them, we're only allowed to keep 2. So min of 4, 2 gives us 2. We write 1 2 times, starting where our left pointer is waiting. Then the left pointer moves forward 2 spots, landing at index 4. The front of our array now correctly looks like 0, 0, 1, 1.
Okay, so now that we've got the logic for this streak strategy down, turning it into code is actually surprisingly straightforward. Let's see how those ideas translate directly.
So what does this look like in code? First, we set up our left and right pointers, L and R, both starting at 0. The main while loop here is the engine. It just makes sure our right pointer, the explorer, goes through the entire array. Inside, we have our streak counter. That's this nested while loop. It just keeps peeking at the next element, and as long as it's the same, it moves the R pointer forward, basically eating up the whole group of identical numbers.
So once that inner loop is done, we know the count of the streak. Now comes the decision. This little for loop is super clever. It runs min 2 count times. So if we found 4 ones, it runs twice. If we found 1 3, it runs once. Inside that loop, we do the writing. Copy the number to position L, and then bump L forward. After that, R gets nudged one more time to land it on the start of the next different number, and the whole process repeats.
All right, let's boil all this down. What are the absolute key things you need to remember from this for your next technical interview?
First up, complexity. This is an O of n, or linear time solution. Now you might see that nested loop and think it's slower, but notice that the right pointer, R, only ever moves forward. It never goes backward. Between the 2 pointers, every element in the array is only touched a constant number of times. And since we do it all in place, space complexity is O of 1, constant space. That's the dream combo interviewers love to see.
Remember these mental triggers. The second you see sorted array and in-place modification in a problem description, your brain should immediately start screaming 2 pointers. And this idea of a read pointer exploring ahead while a right pointer carefully builds the result is a super powerful model. But the biggest takeaway here, think in groups, think in streaks. It's a much more powerful way to solve this class of problems.
And that brings us to a final thought, a really common follow-up question in an interview. How would you change this solution if you could keep at most k duplicates, where k could be any number? With the streak counting logic we just built, the answer is beautiful. You change exactly one number in the code. Min of 2, count just becomes min of k, count. And that's it. That's the power of finding the right generalizable pattern. Thanks for tuning in.